This is 6.3 day one, and today we're going to start talking about polygons being similar and how you kind of show that. So similar just means that your corresponding angles are congruent. So your angles are the same. So angle B equals angle F, A equals E, and so on. But your corresponding sides are in proportion, and that's the different part. I just spelled that wrong. PRO, proportion. That means we are the same shape, different size. Think of a map. The map of Minnesota is still in the shape of Minnesota, but it is a different size. All of the angles in the shape or in the state of Minnesota stay the same. So this angle down here, that's a 90. No matter how big or small I use my map for Minnesota, that will always be a 90. Same with our little top hat at the top of the state. So your angles will always be congruent. That size will not change. Kind of blows your mind a little bit though. Like let's say that was a 70-degree angle, then so is this. It just feels like it would be smaller because the shape is smaller. But the angles do not change. It's the sides that change. So we're just going to list some corresponding angles, like who matches up with who. So we're going to say angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent, to angle G. And angle D is congruent to angle H. So all the corresponding angles must be congruent in order for this to work. Then you need all of your sides to be in proportion. This is called the statement of proportionality, the SOP. And here we're going to match up sides. We'll start doing it with letters because we don't have any measurements here, but as we move into other problems, we're going to use the measurements on each of the sides. So for us, one of the sides would be AB, and that side would go with EF. That proportion has to be the same as side BC going with FG, and CD going with GH, and DA going with HE. So kind of think about a map, like maybe a map is twice as big or it's half as big. All of these fractions have to be that same ratio. One of them can't be wildly different. I can't have this bottom edge of the map be completely different than the other, essentially 3 sides of the state. Your similarity statement then is just saying which shape is similar to which one. So in our case, it could be ABCD is similar to, which is just one wiggle, no equal sign because it's not an equal shape. It is similar to, and then we just need to match the letters up in the right direction. So if I start at A and go around that way, I got to start at E and go around that way. Scale factor is that ratio. It is the ratio, which is just a fraction, of corresponding sides. So like AB to EF. Once you decide which 2 sides you're going to compare, those two in a fraction, that is your scale factor. So now let's do a couple that actually have numbers, so it makes it a little bit more real. So determine if the polygons are similar. If they are, write the similarity statement, and determine the scale factor. So first we need to check and see if they are similar. So we're going to match up sides. So what I tell kids is when you go to the picture, pick out the biggest side, 24, match that up with the biggest side, 30. Now do smallest with smallest, so that'd be 12. Goes with 15. That way you can't be tricked if this shape had been turned or if it had been flipped. If you just look for biggest side and smallest and smallest. Now we're going to do it again. So the biggest side is a 20. And that's going to go with a 25. And the last 2 left are 16 and 20. So we're just making sure that we match up the right sides with the right sides. And then all we have to do is reduce all these and see if they're the same. You can reduce them all. I'm going to grab my calculator. So we can figure out what each fraction can divide by. And I will do that. I'll show you what that looks like. Another way to quick check is to divide each of them. And we're making sure that they all divide to the same decimal. So it looks like they are all 0.8. That's pretty good. So they are, in fact, similar. All of the proportions are the same, and all of our corresponding angles are congruent. So we're going to say F equals Z, and J equals W, and H is congruent to X, and G is congruent to Y. So those are my 4 angles. Check, they're all good. These guys all come out to be 0.8, so we're good there. Check, check. So yes, we are similar. The similarity statement then is just naming one shape. So I'm going to start at G and go GFJH. One squiggle. I'm going to match that up to the other shape, so I got to go YZWX. Last thing it said was determine the scale factor. You can pick out any one of these fractions and just reduce it, and that will be your scale factor. So I'm going to divide by 3. I'm going to divide by 3. That is my scale factor. Oops, sorry, you couldn't see that. You can pick out any one of those, as long as they're all the same. You can pick out any one, and that will be your scale factor. Last one, it actually says that they are already similar, so I don't have to prove it. They're telling me that they are. So find the scale factor and the value of X. So still going to match up sides, although I don't necessarily know who's biggest and largest. It kind of looks like I'm going to match this side up with this one. I'm not sure what X is going to be till we solve it, but since they are similar, I know that 9 goes with 12. I know that X goes with 20, and I know that 12 goes with 16. One other thing you want to make sure you're doing when you are doing similarity is I decided to go left to right. So make sure every one of your fractions is left to right, or maybe you're saying in your head, I'm going small to big. That would also work. Here I went small to big, left to right. Just make sure you're doing it the same way, right? Make sure you're doing it the same way each time, that you accidentally don't flip one of these fractions, or it's going to look like they're not similar. Your job is to solve for X. You have 2 different options. You could use this one to cross multiply and divide, or we could use this one, and it doesn't matter which one you do. I'm just going to do the one on the left. So 9 times 20 and 12 times X. Divide both sides by 12, and we get 15. So that is just a couple of different ways about how we can use similar. This is a portion of the test proving that something is similar, so listing out all the angles and then doing the statement of proportionality.